Hi, thanks for tuning in. Welcome to the Fluids Lecture Series. I will be your guide along this journey as we dive right into fluid mechanics, an essential beginner class for chemical engineering. Why are fluids important to learn about? The reason fluids are so important is that engineers deal with fluids in almost any process that they work on. There are fluids in every single chemical synthesis, inside distillation columns, and even inside your refrigerator. What exactly is a fluid? Most likely you have encountered this term when someone tells you to check the fluids of your car, or in the phrase, bodily fluids. This may lead you to think that fluids are liquids, but this is not always the case. The topic of this class can seem almost laughable at first, but let me remind you what you drink every day. Water, which is a fluid. So no laughing aloud, this stuff can be the difference between life and death. Here's some common characteristics of fluids. Fluids can be in liquid, vapor, or gas form. Fluids deform easily and take the shape of their containers. Fluids are made up of randomly colliding molecules that are in continuous collisions with their surroundings. The precise definition of a fluid is a substance that deforms continuously under the application of a shear stress. For example, when I apply a shear stress to an eraser, it will not continue changing after the force has been applied. However, if I do the same to my coffee, the molecules will continue to deform over time. On a small tangent, there are a few substances that are hard to classify. For example, is a toothpaste a fluid? If you think about it, it actually demonstrates characteristics of both a solid and a liquid, which makes it something called a non-Newtonian fluid. To begin to analyze any types of fluids, we need to understand what we are analyzing and be familiar with systems and control volumes. A system is defined to be a fixed quantity of mass enclosed by a boundary. You can think of the system as something that is inside of an invisible container. The boundaries can be rigid or elastic, but no mass can cross the boundaries. A control volume is an arbitrary volume through which fluid flows. Contrary to the system, the control volume's boundaries are free to be crossed by mass. This is why a control volume is also called an open system. You can think of this as an imaginary border that is put in place inside a pipe, for example. A control volume's boundaries can be real, such as a pipe wall, or imaginary, such as a pipe cross-section. The idea of a control volume will help us later to imagine how much fluid is flowing through a certain place of interest. In this class, we will be using a lot of assumptions and simplifications. Often we will treat systems as ideal, even though they are not, and not focus on smaller details that would be hard to calculate. For instance, this is a photo of a helicopter that was drawn in our fluids class. Engineers do this all the time. To wrap up, here are some questions for review. Question 1. Is peanut butter a fluid? The answer is that it depends on its consistency. It could be characterized as a non-Newtonian fluid if it displays both solid and liquid properties. Question 2. We put Mentos into a bottle of soda, and a stream of soda explodes into your face. Would we classify this as an open or closed system? Even though there is only one region of the boundary where mass can cross, where the soda exits and the air enters, this would still be an open system. Thanks for watching, and see you next time.